So today we're probably come across maybe the most difficult type of equations you can have to do in grade 9 is one with brackets and fractions. Okay, so after that we're not adding any more difficulty on it. Right, so just a reminder before we get going of the stuff we did earlier. Right, if we had an equation like this and we want to solve it, right? We need, on this side, we need to get rid of the 3 and the 8. Which one do we move over first? So here, we need to move the 3 or the 8 off of the same side of the variable. Which number do we move first? 8. And how does it look like on the other side? Yeah, it changes sign. It's positive over here, so it becomes negative on the other side of the equation. Then what we did is we just cleaned this up. 3x is equal to 10 minus 8, which is 2. And we need to get rid of that 3 next. And how did we get rid of that 3? Divide. Okay. Right. Then we increase the difficulty of these questions by introducing a bracket. So with the brackets, what I said was, let's get rid of the brackets first by taking the number outside of the bracket and multiplying it through the bracket. So you go 2 times x gives us a 2x. Okay, and then you go 2 times 4 gives us an 8. But this is a 2 times negative 4, so it is a negative 8. And that equals a 10. Then it becomes like the question we did up above. Move the 8 over by becoming the opposite on the other side. So we have positive 8 this time. Then we divide by 2. Okay? So I just want to remind you of those steps because we sort of need to do both of those steps in these kind of questions. Now, so what we're going to do is solve these equations with fractions in it, and we're going to avoid the fractions just like we did at the beginning of the year, or beginning of this chapter. Right? And so we converted everything to what we call integers, right? Positive and negative numbers. Right? And the math trick that we did to accomplish this is the same one we did in the past and the same one we're going to do now. Who remembers what we did to get rid of fractions a couple of weeks ago? Does anyone remember what step we did? Right? Okay. So what we did is we looked at the two denominators, or how many denominators there were, and we found a common denominator. So in this case, we have a 2 and a 4. What is our common denominator here? 4. And so we took this 4 and we multiplied it to everything. All right, so we multiply every fraction, every term by 4, the numerators. Okay? Then what we did is we compared our denominators to what we multiplied to get rid of the bottom numbers. So you go, hey, how many times does 2 fit into 4? So in this case, how many times does 2 fit into 4? 2. And what we did is we crossed out the 2, crossed out the 4, and put a little 2 up above. Right? So this got rid of the denominator, and what we have left now is 2 times the top. Right? So we left with 2 times the top. So let's just write that out. On the other side, we do the same thing. How many times does the bottom number, the denominator, fit into the number we're trying to multiply? 1. So we go 4 fits into 4 once, and we're left with 3 times 1, which is just 3. So after doing this maneuver, it becomes like a question from like last day. We take the number on the outside and we multiply it to everything on the inside. So we go 2 times the first term. What do we write down? Here, 2x. Okay? Then we go 2 times the second term. What do we write down? Negative 2 or minus 2. And you still have that 3 sitting over. Okay. So So now we analyze our equation and we figure out what to move over. We have a purple 2 and a green 2. Which 2 do we move over first? Purple or green? Green. And how does it look like on the other side? Positive 2. So we take this green 2, we're going to put it on the other side, and we're going to cross it out over here. Right? It just becomes the opposite on the other side for anybody that was away last day. So that's 2x is equal to, when we clean up the right-hand side, what do we get? Yeah, what do we get here? 5. 3 plus 2 is just 5. Now we need to get rid of this 2. How do we get rid of that 2? Divide, yes, thank you. And we divide by 2. Divide by 2 here, divide by 2 here, and those 2's cancel out, and we just left with x is equal to 5 over 2. Okay? Right. So, in summary, to do these questions, the order that we go in is, okay, let's get rid of the fractions by multiplying by the common denominator. Let's get rid of the next step, get rid of the brackets by taking the number on the outside and multiplying through. Then we solve. Okay. Now, what can throw students off is often questions can be written in different formats. So this question is quite similar to what we did here, but it's written in a different format, which can throw students off. So if we have a question like this, I suggest rewriting it to the format we have over there. So and I'll explain as we go along. Here we have a 3 on the top, and this x minus 8, which is off to the side, it really means it's part of the numerator. It's multiplying the numerator. So I can go 3 times x minus 8 like this. Then I'm going to put the 4 underneath like this. So really highlight what's on the top, what's on the bottom. Just rewriting it into a more friendly form. Okay? Then while I'm rewriting this, I'm going to rewrite this, what we have, this mixed fraction we have here as well, into an improper fraction. So what would the numerator for this improper fraction be? Yeah, 15 over 2. Thank you. We multiply, then we add. So 7 times 2, 14. Add the 1, 15 over 2. Okay. So now it becomes a question somewhat similar to what we did before. So our strategy is the same. First thing to do is get rid of these fractions. What is our common denominator here? 4. Right, so we're going to multiply everything by 4. So you're going to put a times 4 here and a times 4 here. And now we're going to cancel. Okay? So we go, instead of 4, can we do 8? Right? Because I want to highlight one point. Because 4 is definitely the better choice, but I want to highlight something else. Let's multiply by 8. It's not the lowest common denominator, but it still works. I just want to highlight something else. Okay? Okay. So our next step is to go, hey, 4 fits into 8 how many times? 2, right? So what we do is cross out the 4, cross out the 8, and we leave a 2 sitting there. Okay, so now we need to clean up what's left over. Now, this is why I wanted to do a 2. So what we do is just multiply this 2 to the outside number, not everything in the brackets. So we go 2 times 3 is 6. Okay, so we have a 6 sitting there, and we have an x minus 8. Okay? Then, on the other side, we want to get rid of the denominator. How many times does 2 fit into 8? 4. So we cancel out the 2, cancel out the 8. We have a 4 sitting there. And we are left with a 15 times 4, which is 60. Okay? So now we multiply. We get rid of those brackets. That's the next stage. So we take this 6, and we put it through the brackets. So we go multiply the first term. What do we write down? Thank you, 6x. We multiply the second term. What do we write down? 6 times 8, what number do we have there? 48. And is it positive 48 or negative 48? Negative, so it's minus 48. Right? And it equals the other side, which is our 60. Okay. So now, which number do we move over? The 6 or the 48? And how does it look like on the other side? Positive. So it becomes the opposite on the other side. So plus 48. Okay? So the 48 goes away over on this side. And you have 60 plus 48 is 108. All right? Now, we need to get rid of that 6. What do? Divide. Divide by 6. Divide by 6. Okay? The 6's cancel out. And 108 divided by 6 is a nice round number. 18. Thank you. And that's it. How is that? Do we need to do one more for practice? Yeah? Okay. Let's do the next one for practice. And maybe I'll just cut one of the word problems out so you have more time to do your assignment. Okay. All right, so this one, the left side is already written in the nice format where the denominator goes under everything. Right? So I'm just going to keep it like that, but I'm rewrite what we have on the right-hand side into a improper number. So what would this one look like? What's the denominator? What's the numerator? 5 over 2, right? We multiply, then add, so that gives us 5, and the bottom number doesn't change. Okay. Right, so now that it's in a nice format everywhere, we look to get rid of those denominators. What is our common denominator here? So we got a 2 here and a 2 here. What would our common denominator be? Just 2. Both of them can fit into 2. So we're going to multiply every fraction, every term by 2. So we're going to take this one, and I'm going to put it in brackets to say we're going to multiply everything on the top here by 2. And multiply everything on the top here by 2. Okay? We figured out what we're going to multiply. Now we get rid of the bottom numbers. You go, okay, how many times does 2 fit into 2? 1. So we cancel out this 2, cancel out this 2, we're left with a 1. So we're left with a 1 times x minus 14, which doesn't change anything, because 1 times anything still stays the same. So I can write down x minus 14 here. Right? Or if you prefer, you want to make it look exactly like what we had last time, you could do that. Right? And now the same thing on the other side. 2 fits into 2 1 time, so we go 5 times 1 left over, which is a 5. Okay? So if we took this 1 and multiplied it through, it doesn't change anything. The x stays the x, the 14 stays the negative 14. If you want to make it look like exactly what we had last time. Okay. So on the side of the variable, we only got one number sitting there. How do we move it over? Do we add, subtract, multiply, or divide? Add, right? We add it to the other side. It becomes the opposite. So it's minus 14 here, plus 14 there. So x equals 5 plus 14, which is just a 19. Right? Okay. And that is it. Okay. So let's just do one word problem, give you plenty of time to work on your assignment. Right? So they're very similar. One involves working with a square, the other one working with a triangle, both dealing with perimeter. Which shape would you rather work with, the square or the triangle? The square. Okay, let's do the square. Okay? And I'm not going to really set up equations. I think these ones work better just by using logic. All right? So it goes, the perimeter of a square is 49.2. So I'm going to draw myself a square. Remember, a square has all equal sides, right? And it's the word perimeter. Once again, remember, it's the distance all the way around. So the distance all the way around this square is 49.2 centimeters. Okay. Right? And they say the length of the side of the square is represented by this formula. Okay? So that is how long one side of the square is. They're asking us to figure out what the value of x must be. Okay? So let's just use some logic without going into the equations first. If they said, and they said that all the way around is 49.2. How do we figure out how long one side is? If all the way around is 49.2, how would we figure out how big one side is? Right? Because remember, all the way around is all we're doing is adding up this side, this side, this side, this side. So how big must this side be? Loriana? Yeah, just divide by 4. They're all equal size. So we take that 49.2 and we divide it by 4. And grab my calculator, and it says 49.2, we divide it by 4, and we get 12.3. That's how big each side is. Right? But they also gave us this formula. So hey, the side is x plus 4.1. I don't know why they said that. Right? And they want us to find the value of x. So if each side is 12.3 and also x plus 4.1, that means these two things are equal. Right? There you go. X plus 4.1 is equal to 12.3. Right? That's how big it is. This is how big this is. It's 12.3. Right? Now, how big is x? How do we find the value of x? Right? We have a little equation there. How do we get rid of that 4.1 on that side? Subtract. It's plus 4.1 over here. Right? And we subtract 4.1 on the other side. So x equals 12.3 minus 4.1, which if I'm first thing in the morning, I think it's 8.2, but I may be wrong. 12.3 minus 4.1, 8.2. Right? So we can say the value of x is 8.2 centimeters. Okay? And that's it. Okay.